Today we will continue our lecture, which is the preventive measures taken to avoid or stay safe from the hazardous effect of the landslide. How we can improve the slope stability or the issues related or how we can deal with the issues related to the hazardous landslides. Here the number one is that effect of water. Make proper drainage network for quick removal of percolating moisture or rainwater by constructing ditches and waterways along the slope. First, the basic principle is that we have to construct the main or proper drainage network for quick removal of percolating moisture. Now there is a need to tell you that what is the percolating moisture. Percolating moisture is the movement of water through the soil itself. Finally, as the water percolates into the deeper layers of the soil, it reaches into the deeper layers. It reaches the groundwater, which is water below the surface. The upper surface of this underground water is called the water table. Hence, we have to install the flexible pipe fittings to avoid water leaks. This figure shows the stability or slope stability profile. Here we have natural slope before the construction, but when we have to construct the structures, man-made structures over the slope, we have to fill the area. And when a sprinkler adds water to soil, the water on the soil in form of the rain or etc. can lead towards the instability of the slope. Building add weight to the slope, which is show that when the building will be made, it will add the weight to the slope, and fill will cause the fill to slide over this slope, and hence we also have removed the vegetation from here, and it will surely cause this fill to slip from its place from here to there on the road. A hill slide become vulnerable to mass wasting due to construction activities. Then this figure shows that if we have a retaining wall here, then this retaining wall without the drainages holes will not play a vital role in controlling this area from sliding from here to there. But when we have the proper drainages channels like this, we have the less subsidence of this area, which prevents this retaining wall from collapsing on this path. Here we have water trapped in the soil causes movement, which is sure pushing down the retaining wall. Then after proper drainages channel like this, water drains through pipe, allowing the wall to keep slope from moving. Then this figure shows that we often see around the mountains where we have stairs like structure, which helps proper drainage of water down the steep slope. If this stair like structure or proper drainage channel is not there, the water will push the soil in its path and results in a debris avalanche or debris landslide. Then this is a big construction of the water channels. Here we have the small stairs like structure. Here we have large stairs like structure, which helps the proper drainage of water from the higher slope to the lower steep slope. Now geological structures also play a vital role in having a landslide or crucial role in the occurrence and behavior of landslide. The main geological factor influencing landslide include the rock type and structure, which is different types of rock and their structural properties, that is sedimentary layer, metamorphic foliation can affect stability. For instance, the layered sedimentary rocks may be more prone to sliding along the bedding plane. Number two, we have the faults and fracture. Fault line and the fractures create weakness in the earth's crust, potentially leading to the landslides, especially if they intersect with the slope. Number three, we have the soil composition and properties. The type of soil and its properties, such as the cohesiveness and the moisture content, are crucial. Soils that are loose or poorly consolidated are more susceptible to the sliding. Number four, we have the slope angle and topography. Steep slopes are more prone to landslide due to gravity. The shape and steepness of a slope significantly influence its stability. Identification of different geological features like fold, fault, joint existence and their morphology, bedding plane dip, angle and lithology, etc. Weak planes or zones may covered or grouted to prevent percolation of water, and this increases the compaction of loose material. Here we have a concept of a fault plane. Then we have the hanging wall and the foot wall. Hanging wall is the rock which is above the fault plane, and the rock which is below the fault plane or fault zone is called a foot wall. Then we have a cross section of hill showing a relatively safe road cut on the left and a hazardous road cut on the right. Then figure B shows the same hazardous road cut after removal of rock that might slide. Here we can see the stable area and the area which is unstable because it has a very steep slope. After its removal, we have limited the sliding land in the form of this less steep slope, which helps to prevent the landslide. Here we can see how proper drainage channels helps to prevent the landslide, and here we have the bedding dip. This term refers to the angle at which the sedimentary rock layers or strata are inclined relative to the horizontal plane. It is a key factor in understanding the stability of slopes and predicting the landsliding risks. How bedding dip affects the landslide? It affects in the form of the slope stability, slide planes, water infiltration and structural integrity. Here we have joints and the bedding failure, which results in a huge disaster. If landslide occurs, the bridge will fall, resulting in this metal bridge to fall. Then we have we identified joint fractures and their patterns to improve the land, and preventive measures shall be taken to improve the land and prevent landslides. Then these arrow shows joints and sites of water percolation. We have discussed earlier that what is water percolation. Water percolation is the movement of water through the soil itself. Finally, as the water percolates into deeper layers of the soil, it reaches groundwater. Then these arrows shows the cross joints which are vulnerable or play important factors in leading towards the landslide. Then we have the arrows which shows the cross joints. Markers show the connected joints, how these joints are connected with themselves. These cross joints are also very crucial towards the landslides. Loose sediments and human interference. Plant ground cover on slopes and build retaining walls. In mud flow areas, build channels or deflection walls to direct the flow around the buildings. Then we have the slope stability techniques. First of all, we treat of slope. How we treat a slope. Then we install different wire mesh nets and fence like this. We have made a practical if we fall a stone. Then we have a practical which shows that if a rock is fallen at an angle of 30 degree, it will fall like this. And when the slope is improved like this, with the area like this, we have a wire mesh here. It will improve the slope stability and less there will be less danger when the material form from here and slides towards there. Then we can see the wire mesh. Wire mesh is commonly known as a rock fall or erosion control mesh. It is used to stabilize slopes and prevent landslides by providing a physical barrier that holds rock and debris in place. How wire mesh prevents landslide? It creates a surface stabilization. Wire mesh is installed over exposed rock faces or steep slopes to prevent loose rocks from falling. It acts as a protective cover that catches and holds rock, reducing the risk of rock fall. It also holds the debris containment. In areas prone to landslide, wire mesh helps contain debris that might otherwise be mobilized by the erosion or slope failure. This containment minimizes the movement of loose material down the slope. It also controls the erosion. By stabilizing the slope surface, wire mesh reduces soil erosion and the associated risk of the landslide. It helps maintain the integrity of the slope and especially in areas with the loose or unconsolidated soil. Here we can see how wire mesh improves the slope stability. We also test, these are the testing material before the wire mesh is installed. We have, this is a stone and there we have a wire mesh, and we checked whether our wire mesh is capable enough to hold this rock like this. It means that this wire mesh is capable enough to hold a rock or boulder like this. Stone free fall testing. This figure shows that the wire mesh is installed to control the erosion or the debris containment. Here we have wire mesh which is integrated with other systems. Wire mesh is often used in combination with other erosion control methods such as soil nails, where we have geotextiles or retaining walls to ensure slope stability. Here the wire mesh is used in association with a geotextile mesh to improve both the rock fall stability and debris slide. Here the sites prone to landsliding are marked with warning signboards that any mankind structures or humans should prevent in moving these places where there are more chances of landslides. What these treatments do, as we have discussed earlier, these wire mesh prevents the or holds the debris containments. This is a debris containment like this. It also prevent the rock fall which comes from upper hill to the lower hill. Here is a visual demonstration that how a wire mesh improves the slope stability and prevent the rock fall. Here we can see another visual demonstration that how wire mesh mitigate the risk of a falling tree down the hill and catches it like this. Then we have the wire mesh in snowy areas where we have a risk or danger of sliding glaciers. So this wire mesh holds the ice or the glaciers with themselves to prevent great disaster and protect the mankind. This is how a wire mesh holds the movement of the glaciers. We also provide wire mesh in our drainages channel, that if a greater boulder comes in the way of our drainage channel, it would be stopped in its way irrespective of moving down the hill and create a great disaster. We also do these installation in river stream channel along abutment etc. to minimize erosion, sediment silting down the stream and gravel, sand screening etc. Here these wire mesh are installed to prevent the erosion from these hills, so that less erosion will cause less factors, or we can say less issues related to these landslide. This is how the wire meshes prevent the erosion along a stream or a river. Here we have the wire mesh which holds the rock fall in itself. We introduced different softwood root vegetation to prevent surface runoff for the soil stabilization. For the soil stabilization, we also provide the wire mesh. Like this. In rocky strata, we do slopes treatment along the bedding, installation of mesh to prevent free falling. If rock is solid or less weathered, we also do rock bolting. Here is also an important concept. We do rock bolting in hilly areas where we have less stable land like this, and we have to provide a road cut. Here is a road cut, and we have to build a road here. Then for stabilization of this land, to prevent from falling here to there, we give rock bolting. First of all, we have to do holes in the rocky strata. Then we have to provide a steel nail, which is usually a steel nut, much bigger nut placed on the threads on end of a cable. Then we have to provide a steel plate and tighten this nut. This ensures the stability and holds the land with itself and prevents from sliding from here to there, causing damage to the newly constructed road. This is how rock bolting is done. First of all, we drill a hole in this in the rock. We can also provide grouting there. First we have to drill a hole and fill it with the shotcrete. This is how the rock bolting is done. Here we have the rocky strata, which is prone to weathering, and after bolting it from different places, it will become a stable area which is less prone to erosion and weathering. We also install different sensors to absorb active landslide sites. In this way, we can respond quickly to affected people, avoid traffic blockage, damming of stream, etc. Sensors play a crucial role in monitoring and observing landslide by providing real-time data on various factors that influence the slope stability. We have different sensors, tilt meters, inclinometers. Tilt meter measures the change in slope angles or tilt of the ground surface. They help detect early signs of slope movement by recording minute changes in inclination. We have inclinometers, monitor changes in it monitor the changes in the angle of the subsurface soil or the rock layers. They are typically installed in bore holes and can detect both horizontal and vertical movements. Here we have a sensor which absorbs the vibrations caused by the landslide and helps to avoid or inform a great disaster in initially, so that protective measures can be done to prevent the landslide. Thanks for watching.